So again, we've been modeling with quadratic functions this unit. We also explored the topic of quadratic inequalities. So today we're going to kind of put them all together. So some review a little bit. In the past, when we're asked where the model, so like a rocket or a ball or something like that, reaches a maximum or a minimum, highest or lowest height or point, what did we try to calculate? Yeah, the turning point or the vertex. So the turning point or vertex. Both are the same thing. And what's that little formula we used to help us find the turning point? Yeah? Good, negative b over 2a. So generally what we would do is we would do negative b over 2a. And that tells us generally how long it takes you to reach your maximum height. And then to find out what the actual maximum height is, you take that value and you plug it in. So whatever you got for negative b over 2a, you plug it back into your function to find the height. If we were asked when the model hits the ground or hits the water, what part of the graph are we generally trying to find? Is he on a roll? Zeros. Yeah, the zeros are the x-intercepts. Very good. X-intercepts are zeros. And we generally do this by factoring. If it's not factorable, you use the graph if you're given the graph or your calculator. And then a third thing where an object was increasing and decreasing is another part that we looked at as well. Okay, questions over that section? Okay. So today we add how long or when an object is above or below a certain point, similar to what you just did on your quiz and what we've been talking about the last few days. So on day one we looked at the same problem. The rocket was launched and it's modeled by the equation negative 16t plus 128t, and the graph is shown below. A is asking on what time interval is the rocket higher than 240 feet? Okay, so we want to know on what time interval the rocket is higher than 240 feet. Okay, well, first let's write an inequality that describes the situation. We're going to take the model. We're going to say negative 16t squared plus 128t. And we're looking at where the rocket's higher than 240. So you think we're going to put less than or greater than? Greater than, because we're looking higher. We're looking above. So it's going to be greater than 240. Just like if the inequality was greater than, like what you did on your quiz, you should look above the x-axis. So in this case, we're looking above 240. So it's really helpful if you illustrate this on your graph. So you go to your graph, you go to 240, and draw a line. So if it's greater than, if we're looking higher than 240, are we looking above this green line or below the green line? Above. So starting at this point right here, we go above the line, and then we stop when we reach that point again. We have to write that interval. What do you notice about that interval? Is it connected or separate? Connected. So what do we know about our inequality? It's going to be connected. It's going to look something like this. Okay, the reason why there's no lines underneath, we're looking at where it's above, where it's higher than. It said at least 240 feet or equal to 240 feet or higher, something along those lines. You would put lines underneath them. In this situation, we just want to look higher than 240, so there's no lines.
So our interval is always going to be the separate.
Yes, inequalities. Okay, so when you look at this first point that green line touches, what is the x value at that point? 3. So it starts being above, it hits 240 at 3 seconds. Above 240, above 240, above 240, and then when does it stop being at 240? 5 seconds. So from 3 seconds to 5 seconds, that rocket is about 240. We take a look at B. It says on what time interval is the rocket lower than 100 feet? Okay, and we want to write an inequality that describes the situation. So you take the model, the equation they gave you. If it's lower than 100, are we going to put less than or greater than? Less than. Lower, beneath, under, it's going to be less than 100. Well, just like we did on the other one, I think it's super helpful if you illustrate that on your line. So you're going to go to where it's 100. And draw a straight line across. And you're looking where that graph intersects that line you drew. So we're looking where the graph intersects that purple line. So if it says below 100 feet, are we going to look above that line or below that line? Below. It says below, so we're going to look underneath it. Okay? So we're looking at this chunk of the graph and this chunk of the graph. Well, is that part of your graph separate or connected? Separate. So what do we know about our inequality? It's going to be separate. Okay? And I'm going to write it like this for what we're doing later. I'll write it like that as well. We'll change it. Okay, so when does our graph start being below 100 feet? Yeah, 1 second, right? So anything less than 1 second is where our graph is below 100. Okay? At what other part is it starting to be below 100? 7 seconds. Okay? Here's the thing. This is a real world situation, right? So can you say that it traveled negative 5 seconds? Can you say that it went negative 25 feet? No. So because we're dealing with real world situations, we can't deal with negatives. We're not allowed to go beyond our x and y axis. Everything has to stay positive. So you'd have to tack on another inequality. Because from 1 second and smaller, it's less than 100 feet. So from 1 second, what x value do we stop at before we get to negatives? 0. So we would have to say from 0 to 100 to 1 second, it's below 100 feet. Okay? If you just left it like t is less than 1, then you're saying infinity. Well, we're dealing with the real world, so we can't go past 0 seconds. Okay? With this piece, right, from anything bigger than 7 seconds, it's below 100. But at what x value do we have to stop at before we start getting the negatives? 8. So we would have to rewrite this one as 7 is less than t, which is less than 8. Because from 7 seconds to 8 seconds, it's below 100. But if you went on to 9 seconds, you're going below the x-axis, and then you're dealing with negative distance, and we don't deal with negative distance in the real world. So you have to have more constraints on these because you're dealing with real world situations. So that's something a little different that you have to pay attention to. On the problems we did prior, you could have left it as t is less than 1. Because it was the real world, you can deal with negatives. That makes sense. I think that's a little different. Questions over there? No. So example 2, Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time can be modeled by that function given, where t is the time in seconds and h is the height in feet. Well, we're going to sketch a graph of Jason's jump. Use window settings. So this is where you're going to need your calculator. Go ahead and get your calculator out. Mine out. You're going to go to y equals, and you're going to go ahead and plug that into y1. Need help plugging it in? Let me know. Happy to help. Alright, go to y equals, plug in that function. And then once you have that function plugged in, you're going to click Window, and you're going to change the window settings to what is in the box here. So look something like this. You change your window settings to match what's in that box in your notes. It should look something like this. If you need help with that, let me know. I can help you with that. And then, once you have that done, go ahead and hit graph. And that's what your graph should look like. If your graph does not look like that, alright, so then you're just going to sketch a graph on your paper. So I sketch mine. But it should look something like that when you sketch it. You just draw all your shapes. Something like this. I'll sketch one as you can see. Something like that. There. Alright. So B, after we sketched our graph, at what height did Jason jump from? Oh, you don't have to do any math for this one. What height did, what was his initial height? What did he jump from? Yeah, good, 480 feet. Whatever this back number is, let's tell you what your initial height is. So you jump from 480 feet. What part of the graph does this represent? Yes? Good. It represents the y-intercept. And the back number represents the y-intercept. So 480 feet, this guy right here. Our y-intercept. So for C, it says how long did it take for Jason to reach his maximum height? Show all work. So we're talking about maximum height. So what did we say we calculated, or what little formula did we first use when we're calculating the maximum height? Yes? Yes, very good. Whenever it says maximum height, we're using negative b over 2a. So what's our b? In other words, what's our middle number? 16. There's a positive 16, so we plug it in, it's going to turn negative. 2, what's our a? Negative 16. We'll clean it up. 2 times negative 16 is negative 32. And what does negative 16 over negative 32 simplify down to? So it takes half a second for Jason to reach his maximum height. And then in D, we want to know what the maximum height is. So what do we have to do with 1/2 to figure out the maximum height? Plug it in. Here's our 1/2. Plug it in. And plug in your calculator. When we plug this in, what do we end up getting? second to go 4 feet higher than where you started from. 484 feet. Okay. Questions over that part? Okay. So for E, it says Jason hits the water after how many seconds? It says show all work and illustrate this on your graph. Now it's important when it says show all work or determine algebraically, that means you have to do the work by hand. If it doesn't specify, you can get away with using your calculator. If it says show all work, show algebraically, you gotta do the work by hand. You can't just use your calculator. You can't just look at the table. Well, we want to know when Jason hits the ground. We talked about this at the very beginning. What part of the graph are we calculating? The zeros. What the x-intercept. So in order to calculate the zeros, what do we have to set our function equal to? 0. So we just take negative 16t squared plus 16t plus 480 and set it equal to 0. What did you say, Jacob?
Squared.
Oh, thank you. Yep. Okay. Well, when factoring, what's the first thing that we do? Yes? GCF. And what can go into 16, 16, and 48? 16. So, sorry, 40. 16. What else do we have to take out with that 16? The negative. There's a negative out front. We have to take out a negative. What are our leftovers when we take out a negative 16? The sticker. Yes. What are our leftovers when we take out a negative 16? Good? Perfect. We divide everything by negative 16. Is there a variable with that negative 16? No. So when I'm solving by factoring, and I have a GCF that doesn't have a variable, it's just a number, I kind of just throw it to the white side. It's less of a headache if you do that. Now, if it just is a factor, you have to have it in your answer. That's why we kind of teach you to keep it. But we just really have to look at what's on the inside because there's no variable with that 16. Okay? If we were just factoring, then you need to leave it. But we're solving, so don't worry about it. Okay? Well, we're splitting the middle, so multiply your first and last to get negative 30. And then what are all our factors of 30? 1 and 30. What else? 2 and 15. What else do we get?
3
3 and
and 10.
10. 5 and 6. Okay. Which of those are going to combine to give us our middle term? Negative 1. Good. How do they have to combine them? Yeah, we want a negative 6 and we want a negative 1, so the bigger number has to be negative. So rewrite your note, your middle. And group. What can we take out? Going from T's and X's. There you go. What can we take out between t squared and 5t? T. And then what are our leftovers when we take out a t? Drop down your middle side. What can we take out between 6 and 30? 6. And then write your leftovers. What are our leftovers? Has to be t plus 5. And we took out a negative, then you have a negative 6, that changes that middle sign. And then we write them together. What's going to go in the first parenthesis? T minus 6. What's going to go in that second parenthesis?
T plus 5.
T plus 5. But we're solving. So what do we get for t when we solve each of those parentheses? You notice you have two answers. Okay? Which of those answers make the most sense? y 6. Ah, good, very good. Real world situations, we can't have negative time. We can't be negative 5. You have to be careful with those. If you have a negative result, then you positive one. So it takes Jason 6 seconds to hit the ground. And again, we said that it's representing our x-intercept or our 0. So this is where Jason hits the ground on our graph at x-intercept. So E is asking on what time interval is Jason higher than the cliff? So higher than 480 feet. Well, just like we did the problems on the last one, was illustrated on our graph. So here's 480. Draw a line. Oh boy. Draw a line representing 480. His initial height. Well, first we gotta write an inequality. Sorry, I like to illustrate first. We'll go ahead and write an equality that represents it. So you're gonna take the function. Oh boy. And if we're going higher than 480 feet, are you doing greater than or less than? Greater than. 480. Okay. More than that. That's right. So we already illustrated on our graph. We went to 480 and drew our line. And we want to write the interval. Okay, well, if it's higher than 480, are we looking above or below? Above. So we're looking above that line. Then you notice is that graph connected or separate? Connected. So we know our inequality is going to be connected. Here's the thing. Do we know what this value is right here, this x value? 0. Do we necessarily know what this x value is right here? No. So when that happens, you have to use your calculator. Go back to your calculator. You're going to go to y equals, and we're going to draw that line in our calculator. To draw that line in our calculator, go down to y2, and just for graphing for y is 480. We're going to draw a line just like we did on our paper. And y equals, type that in and hit graph. So it looks something like this. Now we have to find the intersection points. Well, we use that intersect tool in our calculator. So we're going to hit second, calc, or trace, and then 5. It's really nice because we already know where this first intersection point is. You said it's 0. So we just have to look at the other one. So you just arrow to where it looks like those two lines are intersecting. And then you just hit enter, enter, enter 3 times. You arrow over to where you think they're intersecting, you hit enter 3 times. Okay, so what second is that? What's the x value? 1. So from 0 seconds to 1 second, he is above 480. So starting at 0, he's above 480, he's above 480 at 1 second, he's now back to 480, and then he starts going below. Questions over that? For F, we want to know what time interval is Jason below 50 feet. Well, write the inequality. Say negative 16 t squared. 16t plus 480. Below 50 feet. So we're going to say greater than or less than? Less than. What's the number? Less than 50. Below 50. Well, again, illustrate this on your graph. Go back up here. And you're just estimating 50 feet. I'm thinking like somewhere around here. That 480, 15 is going to be really close to the x-axis. Here's the thing again. Do we know what this x value is right here? No. Okay? So we have to go back to using our calculator, just like we did on that last one. Go to your calculator, go to y equals. Go ahead and clear out that y2 and type in our new 150. And then hit graph. And what buttons do we have to press to get our intersect tool? Second trace box. Okay. Again, you use arrows to where it looks like the two are intersecting. And then you hit enter 3 times. 1, 2, 3. So if you round, it's about 5 point what? 7. So that x value right here is 5.7 seconds. Okay. And we're looking below. Well, that piece below, you have to be careful. Normally, we would just write it as x is less than 5.5. T is less than 5.7. Sorry. But can we have negative distance? No. So it's going from 5.5 to where do we have to stop at? 0, but what's the x value? 6. So from 5.5 seconds to 6 seconds, that's where it's below 50. If you just said x is or t is less than 5.7, that means any value less than 5.7 will work. Well, if we looked at like 10, sorry, greater than, not less than, greater than 5.7, that graph would be below our y-axis, would be way down here. Well, then we're dealing with negative distance. We can't have that. So we have to put more constraints on this. So we would say from 5.5 seconds to 6 seconds, it's below 50.
Why did you say 5.5?
I don't know. Is it 5. I'm writing 5.7. I keep saying 5.5. Questions over that? I think this is kind of a tricky